checking the weather for today here. It's 9 degrees out right now. It's about 6:20 in the morning. Looks like we're going to have a sunny day. Sunrise 7:24, sunset 5:31. Take a quick look at the radar, nothing there. Take a quick look at the clouds. Pretty clear skies. Zoom it out. Looks like we're going to have a clear day. So let's connect up the watts up and do some testing on the solar tracker today. Okay, going over to the NOAA solar calculator here. We can select where the sun is now with this local time. So that's the direction the sun is located currently. I can check the sunrise. Is this green line, so we've got a little bit of time here before the sun actually comes up, but that's the direction. And the sunset will be right here today. So if I zoom in on the property, this will show you what it's like where I'm located with the solar tracker. So the sun currently is coming up over here, right off the, or that's where it's located currently. It'll rise basically 90 degrees from the front of the house, and then it'll go down at this direction later today. So the days are getting longer, looking good. It's just about sunrise here. You can see there's a little frost on the panel. See how long that takes to burn off. But we're supposed to be clear sky all day. So it's getting in position. As I mentioned, the sun will be coming up right 90 degrees from the house here. So it's programmed to point exactly where the sunrise is going to be from an azimuth standpoint. There we go. Alright, let's get the watts up set up and we'll go from there. Okay, got the watts up connected, and then I have it programmed at 3-second capture rate, and I'm also capturing the watt hours to see how that calculates it by itself. So we'll check back later. Alright, sun's up. Nice and bright on the tracker. Pretty big angle to the big panels, but it's nice to see the sun. Alright, you can see we're getting about 60 watts on the tracker. The total system's doing 110. You can see having a tracker pointing towards the sun gives you the bulk of your power. Only getting 10, 12, 14 watts on the big panels. Looking good. Oh, just got past solar noon here. Tracker's doing great. Let's go look at the wall. Alright, we're a little bit higher than the other day, 519, about 98 on the tracker. The rest of the panels, pretty typical 100 watts on these guys. Alright, I've got the data all loaded in from today's run here into my watts up logger. Came in on the table here. If I look at the max I got today, the highest reading was 104.6 watts into the grid from the tracker. If I look at the graph of the watts, you can see it came right up very early, stayed with the sun as the sun was rising, and peaked out here a little over 100 watts. Nice square profile, and then as the sun was hitting the horizon, it dropped right off. So let's compare that to the run from the other day. Alright, I've got the data from February 6th for the system loaded into the spreadsheet here. And I also have the data from today, February 8th, for the tracker loaded in here. If you remember the system one, we peaked out a little over 500 watts. and then today with the tracker peaking over a little over 100 watts. Now if I take that tracker profile and nominalize it with the system profile so that the peaks line up exactly right, you can see that you get a benefit as the sun is rising. A tracker system would be able to stay with the sun as it's rising, getting a higher overall output all the way up to the peak solar noon, about equal with a fixed panel all the way through the solar noon period. But then as the sun starts to drop in the sky and head more west, that the tracker is able to stay with it longer, basically giving a much better performance here following the sun. And then eventually when the sun starts to hit the horizon and some of the obstructions, it'll drop right off. So that's the data for today. Talk to you later.